Your AI agent just answered a critical question. It sounded confident, articulate, maybe even eloquent. It also was completely wrong. Here's the uncomfortable truth about single AI agents. They don't know what they don't know. They can't raise their hand and say, actually, I'm not sure about this one. They just answer confidently every single time. And that's fine when the stakes are low. But when you're making decisions about patient care, financial transactions, or legal compliance, confidence without verification isn't a feature. It's a liability. Today we're going to talk about why one brain isn't enough and how multi-agent systems solve a trust problem that single agents can't. So let's talk about the real problem. A single AI agent is like a brilliant new hire who never says, I don't know. They always have an answer. They deliver it with complete confidence, and sometimes, often enough to keep you up at night, they're dead wrong. This is the hallucination problem. And before you ask, no, it's not getting fixed in the next software update. It's fundamental to how large language models work. They're trained to produce plausible sounding outputs, not to recognize the edges of their own knowledge. And it gets worse. Single agents don't just hallucinate facts. They hallucinate confidence. There's no internal uncertainty meter, no hesitation. No, let me double check that. They'll tell you the wrong answer with the exact same conviction as the right one. It's like a GPS that never says recalculating. It just confidently drives you into a lake. For low stakes, fine. Summarize this email, draft a tweet. No one's getting hurt. But high stakes decisions, medical recommendations, loan approvals, compliance checks. Would you bet your company or someone's health on a system that's constitutionally incapable of saying, I'm not sure? High-stakes applications like healthcare or finance demand systems that can assess uncertainty and verify outputs before making critical decisions. Now, this might sound like an unsolvable problem, but humans cracked this centuries ago. In medicine, we invented second opinions. You don't go to one doctor's and take a serious diagnosis and hope for the best. You consult specialists, maybe a tumor board, which is literally a room full of experts arguing about your scans until they reach consensus. In finance, there's the 4I principle. Two people sign off on significant transactions, not because bankers can't count, but because we've learned that single points of approval become single points of failure. In aviation, pilots have co-pilots. Checklists exist because even the best experts miss things under pressure. The whole system assumes humans are fallible and designs around it. This is institutional wisdom earned through disasters. Humans learned, sometimes the hard way, that trust comes from verification, not confidence. So why are we building AI systems that throw all that wisdom out the window? Let me tell you about the greatest multi-agent system ever built. And it was built in 1969. NASA's Mission Control. When Apollo 11 was descending to the moon's surface, there wasn't one person making the call. There were dozens of specialists, each an expert in one specific system, all monitoring simultaneously. You had Guido watching the guidance systems, Fido tracking flight dynamics, Ecom monitoring life support, and Capcom talking to the astronauts. And flight director Gene Kranz orchestrating all of it. And here's the key. Before any critical decision, Kranz would run what's called a go, no-go poll. He'd go around the room, each specialist would check their systems and call out go, no-go. One single no-go from any station, the whole mission pauses until it's resolved. Now here's where it gets dramatic. During Apollo 11's descent, alarms started blaring. 1202, 1201. The lunar model's computer was throwing errors nobody had seen in simulation. Guido, Steve Bales, had seconds to make a call. Abort the landing or press on. One brain, under pressure, could have scrubbed the whole mission. But Bales wasn't alone. He had a back room full of experts. Jack Garman, a 24-year-old engineer, recognized the alarm as a computer overload that could be ignored if it was intermittent. He told Bales, Bales called go, Kranz accepted. 40 seconds later, Neil Armstrong landed on the moon. That's not a single agent making a decision. That's a multi-agent system, specialists, redundancy, verification, and a clear protocol for resolving disagreement. So you could say we've been doing multi-agent systems longer than most people realize. So how do we bring mission control into AI architecture? Instead of one agent answering, you design a system. One agent generates the answer. Fast, creative, first draft thinking. Another agent verifies. Cross-checks facts, catches hallucinations. This is your Jack Garman, the specialist who actually knows if that alarm is a real problem. And a third agent that plays adversary. Its job is to break things, find the flaws, ask what could go wrong. In security, we call this red teaming. In AI systems, it might be the most important agent you build because nobody else is trying to make your systems fail. The goal isn't consensus for its own sake. It's earned confidence. When multiple agents with different perspectives agree, you can actually trust the output. When they disagree, that's a signal, dig deeper, escalate to a human, don't just ship it. This is the 4 eyes principle automated. This is the tumor board at machine speed. This is institutional wisdom built into the architecture. Now look, I'm not saying every chatbot needs a mission control room behind it. If you're building something that recommends movies or summarizes articles, single agent. Keep it simple. The worst case scenario is someone watches a bad film. This is low stakes. But here's the question I'd ask. What happens when your AI is wrong? If the answer is mild inconvenience, single agent is fine. If the answer is lawsuit, patient harm, regulatory violation, or my CEO calls me at 2 a.m., you need verification built into the system. Healthcare, finance, legal, safety-critical operations. These are exactly the domains where teams want to deploy AI agents. And these are exactly the domains where single agent confidence will eventually become front-page news. The question isn't whether you can afford multi-agent architecture, it's whether you can afford to explain to a judge why your AI was so confident about the wrong answer. The cost of implementing multi-agent architecture is justified when building systems for high-stakes environments where errors can have severe consequences. What we learned today is that we solved this problem already. 60 years ago, NASA built a system where no single person, no matter how expert, could make a critical call alone. Every decision passed through multiple specialists. Every go was earned, not assumed. They did it because lives were on the line, and it worked. If you're building AI systems that make decisions that matter, you have a choice. You can trust one agent and hope it's right, or you can build a verification into the architecture the same way we've done for medicine, finance, aviation, and space exploration. One brain has blind spots. Multiple brains catch what others miss. That's not overhead. That's how you build systems worth trusting.